the magnetic field? We change it from V0 to 0. So you would find here the angular momentum minus pi lambda v a squared with the plus sign times v0. So that is the angular momentum that would be transferred to the wheel, and as you can see, it's independent of time. It just depends on the initial magnetic field. 3-minute break.
3-minute break.
You need 3-minute break.
Okay.
Huh?
Yeah.
I know, I mean, you, all of you. If you want to go out and get some deep water. Are you okay? Okay. Well, if you are okay, then I will proceed. All right. It says a long solenoid with radius A and n turns per unit length carries a time-dependent current IOP in the p direction. Find the electric field magnitude and direction at a distance s from the axis, both inside and outside the solenoid. So basically what it means is that if you are given this long solenoid, it has a time-dependent current, and we assume the change in current is not rapid. It's called the quasi-static approximation, and we assume we are in that regime. Otherwise, things would change. But for this, we assume that the change in current with time is not very fast. So if you have this change in current and in the solenoid, and if you have a closed circular wire with radius s, or with some radius r, that is one is less than the radius of the solenoid. That means if you put it inside the solenoid, what would be the induced field on that circular loop? Or if you have a bigger one, which is greater than the radius of the solenoid, what would be the induced electric field? So it's just pretty straightforward. You just start from that equation and find the electric field. So example 214. So I will just use two-dimensional view, x, y, and imagine that the z-axis is pointing towards you. So let's say this is the view of the solenoid. So imagine that you have this long solenoid of radius A. It has radius A, and number of turns per unit length is n. Number of turns per unit length. And so the current is a function of time, I of t. So this current is flowing in the p direction. So for the p direction, so that means the magnetic field is going to be. So if you have a current that flows like that, that's the flow of the current. then the magnetic field is going to be in the positive direction. So for a long solenoid, I can write B equals to mu naught N I along the plastic direction. So our objective is to find the induced electric field if you have a loop first head inside of radius S. So you from Faraday's law, the integral of E dot dl equal to minus d phi by dt, and what's going to be the flux through this loop. So you can think of the direction of the magnetic field coming out. So that's the vision. So the flux bounded by this conducting loop phi is gonna be just a mu naught Ni times pi s squared. And you know the electric field is gonna be tangential to at any point in the conducting loop. So integral of E dot dl, that would give you just 2 pi s times E. So E times 2 pi s equal to minus of d by dt of the flux, which is mu Ni pi s squared. So what's changing with time? I, so not s.
I have a question.
Yes.
When you said the flux, were you talking about the flux going through the loop inside the solenoid?
The flux going through this wire. So this is the conducting wire. This is conducting.
Is that not a ratio of the area of the wire to the solenoid?
No, we are talking. Okay, the solenoid. The purpose, the job of the solenoid is to provide the magnetic field,
Right,
which gives you this much magnetic field
right.
that points out. So what I'm talking about the flux is the flux through this region.
So we don't even have to worry about the solenoid being there particularly. We just have a.
Yeah, you after you get the magnetic field, you can forget the solenoid.
Okay.
Yeah,
We should go ahead.
yeah. You know the purpose of the solenoid is to give you this magnetic field. That depends on time because I changes with time. So so E 2 pi s is gonna be mu naught N pi s squared di by dt. So that induced electric field is gonna be mu naught pi mu naught N s over 2 di by dt along the t direction.
We're missing a minus sign?
Yes, with the minus sign. So that is if you have a conducting wire placed inside the solenoid, which is center coinciding with the axis of the solenoid. Now, the only difference if you have a conducting wire